Hi all, today I'm going to talk about how to find 3D structure of molecules or valence shell electron pair repulsion or geometry of the molecules. In the 2D structure or Lewis structure, we talked about how to draw the molecule on the paper, just, just Y and X axis, just horizontal and vertical lines on the paper. But in the 3D, we want to find the 3D structure of them, X, Y, and Z axis, including X, Y, and Z axis. And we want to draw it again on the paper. So we're gonna show you how we can draw the 3D structure of that and how we can find the geometry of these structures. So VSEPR theory is based on the idea that electron groups, including lone pairs, single bonds, or multiple bonds, repel each other. This basically is uh, what is around the central atom. We're talking about the electrons around the central atom. This repulsion between the negative charges of electron groups on the central atom determines the geometry of the molecule. So basically, the electrons are negative charges and there are not enough space around the central atom. They don't like each other, they don't tolerate each other, so they want to take as distance as possible from each other to be safe. Like coronavirus situation, we have to stay at home and take distance as much as possible to be safe, right? So the electrons do the same. In nature, they want to make as distance as possible. So that's why the geometry of the molecules form. So how we can predict the geometry of molecules using VSEPR theory or using valence shell electron pair repulsion theory that I talked about. The repulsion between electrons makes the geometry of molecules. The first thing is draw the Lewis structure of the molecule. Here, I'm going to talk about only Lewis structure for molecular compounds and the geometry of molecular compounds, okay? So we only gonna find the geometry and we care about the VSEPR of the molecular compounds, the non-metal and non-metal molecules. Non-metal and non-metal elements. So first, we should draw the correct Lewis structure. If you do not draw the correct Lewis structure, the other steps will be wrong, basically. So you will basically don't get a full credit in the exam. So the first step, if you do not know how to draw the Lewis structure, to go back to my previous video and be able to draw the Lewis structure of molecular compounds, okay? Then after we find the correct Lewis structure, we should determine the generic formula of the compound. How we find it? In the generic formula, A is the central atom, X is terminal atom, and E is a lone pair. So we basically give a name or letter to each of these elements. Whenever we see central atom, we call it as A. Whenever we see a terminal atom or the corner elements, we call them X. And whenever we see a lone pair around the central atom, we call it E. Then there is a table, we refer to it, and we find the geometry and the 3D structure of the molecules. Okay, let's see how we can find the geometry of the CH4. So the first thing we do, we should find the Lewis structure of the CH4. So please pause here and see if you can find the Lewis structure of CH4. So that's the Lewis structure for CH4. Then we should find the generic formula. So what's the generic formula? A is always central atom, always comes first. Then we have terminal atom, there are four, and we have lone pairs. If there is a lone pair around the central atom. So the generic formula for CH4 is AX4. Do you agree with me? So C is central atom, right? And we said that we named the central atom A. So, and always central atom will be first, A. We have four terminal atoms, would be four X's, right? X4. Do I have any lone pair around the central atom? No, right? So the generic formula will be X4. And then we're gonna go to a table and find the X4. What was the generic formula for CH4 is X4. So I find under the column of generic formula X4 and I go this row belongs to X4. This is the territory for X4. Whatever is in this row belongs to X4. So here is the 3D structure of X4 or CH4 here. What are these hashed lines or dashes and wedges here? This is a wedge. When you have a bold line here is a wedge. It means that the hydrogen is toward you, into the monitor. From the monitor outside toward you, that's the hydrogen. When there is a hashed line or the dash line, it means the hydrogen is to the back of the monitor, outside of the monitor from the back. So, and the top one shows the lone pair, and the straight line shows that the line is in the paper. So this shows that we can draw on the paper the 3D structure of the molecule. When we put a bold line, we show that a molecule, basically the bond is toward us. When we show the dash, it means in the back. And then when we write down the dash line, it means in the line of the paper. And this is a lone pair. We just show it like this. Here we talked about the X4, right? So X4, that's the structure for X4. We have hashed line or dashed line here, and we have the bold line here. It shows that it has four bonded atoms around it, right? 1, 2, 3, 4. There is no lone pair around the central atom. The molecular shape or molecular geometry is tetrahedral. Electron geometry is tetrahedral. Here is an example for it. So you can pause and try to draw the Lewis structure, find the generic formula and 3D structure and molecular and electron geometry of it. You do not need to worry about hybridization. And here is the bonded angles, the bond angles. I will provide this table for the exam for now, so you do not need to memorize this table. Thank God, right? Okay, so here we found that it has the molecular and electron geometry of the tetrahedral. The bond angle is 109.5. Here you can see the here the left picture shows the ball and stick model, and the right picture shows the space filling model. The space filling model more portray molecules, and the ball and stick model are often used to show the geometry of the molecule. You can see here that we can here see the bond angle that is between CHH, shows the 109.5. What picture is basically remind you this picture, do you think? Or this geometry? Like pyramids in the Egypt, right? This is the pyramids in the Egypt, basically structure. So we basically show that we are talking about the 3D structure, X and Y and Z axes. Okay, what is electron geometry? The geometry you call arrangement of the electron groups, including lone pair in the central atom. If you have a lone pair in central atom, the electron geometry included. The molecular geometry is the geometrical arrangement of the atoms don't include the lone pair of the central atom if you have a lone pair. If there is no lone pair around the central atom, electron geometry and molecular geometry will be the same. Again, if there is no lone pair in the central atom, the electron geometry and molecular geometry will be the same. I will show you in the next slides. Okay. You can see here that, for example, you don't see for AX3 no lone pair around the central atom. So the electron geometry and molecular geometry will be the same. But when we have a lone pair, for example, AX2E, the molecular geometry or molecular shape is the same, and electron geometry will not be the same. So please pay attention to this. Okay, let's do another molecule. I'm gonna talk about NH3 here. So let's draw the Lewis structure, the first step. Here is a Lewis structure. Then we find the generic formula. Let's do it together. A is central atom. What is A here? Is N, right? Then how many terminal atom I have? 3, right? I have 3 X's here. Do I have any lone pair in the around the central atom? Yes, I have lone pair. To make it more visible, I just put it down more. So here I have one lone pair. So what's the generic formula here? AX3E. And let's go to the table. We find AX3E, and all of these row in this row belongs to XX3E. So it has 3 bonds basically around it. It has one lone pair. The molecular shape or molecular geometry is trigonal pyramid. Electron geometry is tetrahedral. So it's not the same, the molecular geometry and electron geometry, because there is a lone pair around the central atom. And this is the example. You do not need to worry about hybridization at this time. And that's the bond angle. So you're going to copy from here and you write whatever they ask for in the exam. That's basically it. You just copy from this table as long as you find the Lewis structure. And then the generic formula, you're going to copy this row based on what is asking for in the exam. The electron geometry is tetrahedral. The molecular geometry is excluding lone pair is trigonal pyramid. So if you remove this lone pair, this would be trigonal pyramid. But when I include the lone pair, is tetrahedral. The bond angles of NH3 because of this lone pair is a little bit smaller than the tetrahedral bond angles, but we don't show it in this table, so you do not need to worry about it at this time. In the higher levels of chemistry, they tell you more about it. Let's do CO2. Let's first draw the Lewis structure for the molecule, then the generic formula. The generic formula is what? I have one central atom, I have two terminal atoms. Do I have any lone pair around the central atom? No. So that would be AX2. I go to a table, I find AX2. This row is the territory of this molecule. This is the 3D picture. Do I need to show any dash here or wedge? No, because I can just write it as a straight line on the paper. There are two bonds around the carbon. There is no lone pair. It's a linear electron and molecular geometry. CO2, you do not need to worry about hybridization, and the bond angle is 180. Okay, let's do water. Water, the Lewis structure for water is this one. And then what's the generic formula? The generic formula is AX2E2. So I'm going to go to a table and find AX2E2. That's the 3D structure for it. There are two bonds around it. There are two lone pairs. The molecular shape is bent. Electron geometry is tetrahedral. That's the example. You can do it. And the bond angle is 109.5. For water molecule, the same. The bond angle is, because of the two lone pairs, is even smaller than NH3 bond angles. But you do not need to worry about it. Just what you see on the table as a bond angle as it is. Okay guys, what about if we have more than one central atom? You should find generic formula for each central atom. Okay, that's really important. If we have more than one central atom, we should find the generic formula for each central atom. For example, CH3OH, here is a Lewis structure for it. It has two central atoms. You might ask, okay, how I know that CH3OH has two central atoms? How I can draw the Lewis structure? These are organic compounds, guys. In the organic compounds, because most of them are carbon and also oxygen, most of the times carbon is central atom. Okay, so we should write carbon central atom and oxygen here next to it as a central atom, because the other atoms are hydrogen, and we said before that hydrogen is always terminal atom. Another thing is that this is all practice. As you do practice and draw the Lewis structure, you kind of becomes a little bit more automatic for you that you draw the Lewis structure. So here we draw the Lewis structure. We make sure you have around each element. We follow the octet rule and 8 electrons. Then we should find another step after the finding Lewis was finding generic formula. I find generic formula for each central atom. Let's see, carbon is one central atom. Why? Because there is more than two elements around it. So one C and H, one C and H, one C and H, and one C and O. Oxygen here is terminal atom for carbon. So it has the generic formula. This carbon has a generic formula of X4. What about this oxygen? It has two bonds, one with H here, one with C here, and it has two lone pairs. So the generic formula for it will be X2E2. So I would recommend you put your hands in the first in the right side and only see the carbon and four bonds. Then find the generic formula for it. Then put your hand in the left side on the carbon and try to find the generic formula for the oxygen. So you can find that is X2E2. So then we go to the VSEPR table and find the uh, all of these the whatever is in that row for that central atom. For example, for the X4 that I said, this row is belongs to the X4. Whatever is central atom is X4, this associated to it. And another one that we found for oxygen was X2E2. So this row is belongs to the central atom which has a geometry of X2E2. So here this X4 has the electron geometry, e.g. I just abbreviated to its electron geometry, and Mg is molecular geometry. So it has the electron geometry of tetrahedral and molecular geometry of tetrahedral. The shape is, you can see in the row of the X4, the 3D structure for it. And for the X2E2, the electron geometry is tetrahedral and the molecular geometry is bent. The same goes for C2H6. Whenever you have organic compound which has loss of carbon, here two carbon, you very quickly put the two carbons back to back. Okay, then you're gonna attach the hydrogen to it, to each carbon, to find four bonds around it or 8 electrons around each carbon. Then we found the generic formula for each central atom. So here I have one central atom. See, it has, if you put your hand in the right carbon, you see that it has the left side carbon has four bonds. So the generic formula has X4, and when you put your hand in the left side carbon, you see that the generic formula for the right side carbon is X4. Why? Because it has four bonds around the carbon. So when we go to a table again, we can find that X4, this row belongs to when any molecule that has X4 or any central atom that has X4, generic formula.